Hello students, welcome to the EPG Pathshala. I am Dr. Imtiaz Hassan from Jamia Millia Islamia, Central University, New Delhi. Today I am going to talk about module differential centrifugation and density gradient centrifugation from paper centrifugation techniques. In this module, we are going to discuss the following thing in detail. First is the basic concept of the differential centrifugation, how it is differed from the normal centrifugation process. And then second is what is the actually differential centrifugations, what are the main advantage, what are the main features of the differential centrifugation. Then what is the density gradient centrifugation process. Then we must discuss about the suitable density gradient medium selection, what are the criteria for the selection of the suitable density gradient medium, what are the conditions to apply different types of density gradient medium, what are the ideal situation to apply the suitable density gradient medium. Then there are some additive used for the density gradient preparation. Again, we will discuss about what are the ideal additive, in what condition, what kind of additive can be used for the differential centrifugation process for the separation of cell organelle and any other biological macromolecules. And at the last, we will discuss about the equilibrium sedimentation process that is used for the separation and calculation of some information about the particular molecules. So the basic the basic concept of centrifugation, that a centrifuge is a device for separating particles from solution according to their size, their shape, their density and viscosity of medium, and of course the speed of the rotor. In biology, the particles are usually cells, subcellular organelles, viruses, large molecules such as proteins and nucleic acid. So the separation of these molecules actually is dependent upon the sedimentation coefficient of the particle, which is given by the Sedberg, and it is known as Sedberg unit. So the forces applied to the molecule is actually the gravitational force, and the centrifugal force that is applied depends upon the speed and time and the radius of the rotor. So we are discuss about the once you talk about the differential centrifugation. Differential centrifugation are of again two types, classified into two groups depending upon the application. What are the possible application? First is the analytical centrifugation. Analytical centrifugation involves measuring the physical properties of the sedimenting particles such as sedimentation coefficient, molecular mass, binding capacity and the many other parameters. But the other part is the preparative centrifugation. The preparative centrifugation is the objective of preparative centrifugation is to isolate a specific particle which can further be reused. That is the main difference between analytical and the preparative centrifuge. In analytical, the particle may or may not be utilized further, but in the case of preparative centrifuge, that substance or that particle may further be utilized for the other purpose. There are many types of preparative centrifugation such as rate zonal centrifugation and differential centrifugation, isopycnic centrifugation. So we are going to discuss all these types of centrifugation, their application, their advantage, disadvantage in detail in this module. We are going to discuss about the densities of the different biological materials, because in the differential centrifugation the density is the important factor. So you must have the idea about the densities of the molecules. Like the RNA, it is the smallest molecule and it has the density of 1.9 gram per cc, and the DNA which having the 1.7, ribosome it's little bigger molecule, it having 1.6, the nucleus of the cell it having 1.32, and the chloroplast, the density of chloroplasts is ranges from 1.21 to 1.24. Then the mitochondria, it is from 1.18 to 1.20. Endoplasmic reticulum, it is 1.11 to 1.12, and the lipid body is having a very low density, it is 0.96. So you can see that these are the values used for the measurement of the binding density, and on the basis of this density molecules got separated in during the differential centrifugation. we will give you the idea about the how Stokes equation is applied for the centrifugation, especially in the case of differential centrifugation. In the earlier centrifugation, usually the liquid medium is the water, but here we have to add certain high density medium which can separate the molecule, and therefore the viscosity of medium is a very essential factor to separate the molecule. So as Stokes equation describes that the sedimentation velocity is proportional to the d square into difference in the density of the particle and the liquid medium multiplied by g and divided by 9 eta. Eta is the viscosity of the liquid medium. So you can see the diameter of molecule is very essential factor to separate out, and in the same time the density of the molecule as well as the density of liquid medium, and especially the difference in their density medium is actually implies or actually the main factor to separate the molecules of the different size. Then the viscosity of medium is equally essential because it actually applies the friction force or the viscosity, that the force acting on the particle is different. That's why it separates the molecule, and G is the gravitational centrifugal force. We are going to discuss about the sedimentation coefficient of the molecule, because the molecules of the different molecules have their different sedimentation coefficient. So it was given by the sedimentation coefficient value was given first time given by Theodor Svedberg, and during his analytical ultracentrifugal studies of proteins and ribosome. If you divide the terminal velocity with the G, that is the gravitational field force, then it gives you the Svedberg unit. So the Svedberg unit is nowadays widely used, is a defined properties of the particular molecule, and it ranges from 10 to the power minus 13 to 10 to the power minus 11 second, and usually one Svedberg unit is correspond to 10 to the power minus 30 second. So different molecule having different Svedberg value, so it is used as 30s 40s ribosome. It means that the 30 Svedberg means it is a 30 into 10 to the power minus 13 second. So the Svedberg is a very common unit in this case of centrifugation and widely used today during the separation of molecule and measurement of the properties of the biological macromolecule. The sedimentation coefficient value of the some biological molecules, common biological molecules like the cytochrome C, it is a very small protein and it is having the S value is 1.7s. Transfer RNA having 4s, and the eukaryotic ribosome, you aware that it is eukaryotic ribosome is 80s, but it is having two subunit, one is the 60s and one is the 40s. Similarly, prokaryotic ribosome is actually 70s, but it having the larger subunit as a 50s and the smaller subunit as a 30s. If you talks about a bigger molecule like the tobacco mosaic virus, it having the Svedberg value S value as 200s, and the mitochondria having the 20,000 to 60,000 S. So these are the S values usually used for the calculation or measurement of the properties of the biological molecules. So this centrifugation is classified into mainly two groups. One is the differential centrifugation and one is the density gradient centrifugation. So in the differential centrifugation, cell-free extract and supernatant are centrifuged at progressively high speed for the longer time to get it separated. But in the case of density gradient centrifugation, cell extract are centrifuged through a medium whose density gradually increases towards the bottom of the centrifuge. So in the differential centrifugation, there is no density gradient kind of thing, but in the case of density gradient centrifugation, there are a certain medium which having their own viscosity, they have own density. So the difference in the density of particle and density of the medium is main important factor for the separation of the molecules. So the density gradient centrifugation is further classified into two groups. One is the rate zonal centrifugation, other is the isopycnic solution. Both types of centrifugation is depends on the density gradient, but they have some minor differences. So in the rate zonal centrifugation, sample is centrifuged until the most dense component approaches bottom of the centrifuge tube. But in the case of isopycnic solution, sample is centrifuged until the all component reaches their equilibrium biointensity. So In the red zonal centrifugation, samples are kept at the top and start to settling towards the bottom side. But in the isopycnic method, the samples are mixed throughout the tube and it settled as per their. They achieve the equilibrium of the buoyant density with the medium. In the case of differential centrifugation, you can see that differential centrifugation obtains a separation of two particles from the mixture. Separation may end up in a supernatant or in a pellet, or it may be distributed in both fractions depending on its size, shape, density and conditions of the centrifugation. Like you can see here in the picture that the first you take the cell homogenate, then filtered it and you run at the small RPM or small g like the 600 G for the 10 minutes. The bigger molecules got settled down at the end. Then you take out the supernatant, further put it in the different tube and again centrifuge at the 15,000 G for 5 minutes. You can see here the another molecule like the another cell organelle like the mitochondria, chloroplast, lysosome and peroxisomes are settled. Then you take out the supernatant and centrifuge again at the 1 lakh G, and you found that the smaller molecules like the plasma membrane, microsomal fraction, fragments of endoplasmic reticulums and large polysome bodies are got separated. Then you further increase the centrifugation rate, then the ribosomal subunit and polysome subunit got separated, and at the last you take the soluble cytoplasm or the cytosol. You can see here the differential centrifugation means the different speed you can take the different molecules separate out from a mixture of the different size. So that is the widely used technique for the fractionation of the cell organelles. So I'll give you the brief description of the differential centrifugation. This technique is sometimes also referred as differential sedimentation. As name indicates, differential means that differs in the mass and the size, and it is essentially a process of successive centrifugation, single or repeated steps with increasing centrifugal forces. So first you have to centrifuge at certain speed, then increase, so there is difference in the increase in their centrifugal forces causes settling of the particles of the different site at the different speed or different time in the tube. The separation is predominantly depends upon the particle mass and particle size, where heavier particle or cell settle first at the lower G value. Like intact cells can sediment at around 800 G, and less heavier or less denser particles settled at later. However, in many cases, differential centrifugation is used to separate out intracellular matters, and thus this method is also important, so-called subcellular fractionation method, because if you take a cell component, all the cell organelle having their different density or different mass or different size, that's why once you go to the centrifugation process, these particles are separated down at the different speed and they can be separated one by one. During subcellular fractionation, various markers can be used as a quality control to measure or giving an assessment of the quality of separation of individual fractions. The density gradient centrifugation. Here people make the density gradient. So the density gradient is the sucrose density gradient, where the density you can see here it is varies at the top. At the lowest part is the density is 1.25 and at the top it is the 1.09, and the organelle fractions are kept at the top and then it is centrifuged at the very high speed. So the particle of the different size got settled into the different gradient. Yeah, like you can see here the peroxisomes are the smaller molecules, so peroxisomes are settled at the lowest part, then the mitochondria and then the lysosome. So this density gradient centrifugation usually makes the density of the medium, used generally sucrose, and then the organelle are fractionated on the basis of their different densities of the cellular fractionation. Density gradient centrifugation. As the name implies that the density gradient centrifugation utilizes the specific medium that gradually increase in density from top to the bottom in the tube. So there is a gradient in a tube from top to the bottom with the increasing from the top to bottom. This means that under centrifugal force, particles will move towards the medium and density gradient and stop at a point which density of the particle is equal to the density of the surrounding medium. So the Purpose is to separate the molecule based on the density by creating a particular density. So there are different types of medium used to create the density gradient that depends upon the desired outcome. The density of gradient can be established in a tube either or in a isopycnic way. We describe the types of density gradient centrifugation. Then generally there are two types of the density gradient centrifugation. One is the rate or zonal centrifugation, another is the isopycnic solution. So in the rate or zonal centrifugation, there is some zone of the particular density appears in the centrifugation tube. You can see here the particle of the different density separated at the different zone. In the case of isopycnic solution, there is a density gradient from top to the bottom, and the molecule, once the molecule achieves their similar kind of density with the medium, they got settled down and they got settled there, and accordingly they will fractionate into the band, and the band of the different density will be separated out. You can see further illustration of the both types of density gradient centrifugation, like in the rate zone centrifugation. There is a sucrose density gradient medium, and the all cell organelle, for example, we take the cell organelle with the different S value, are put at the top and then centrifuge for the particular time. So you can see after 0.5 hours the molecules got start separated. After 1 hour the more separation occurs, and after 2 hours all molecules are separated according to their S value at the different position in the tube. In the case of differential centrifugation, the molecule mixed and then centrifuged at the different hour, like you can see 2 hours, 4 hours and 8 hours. So the cesium chloride density gradient, you can see once the molecule achieved their own density, it got fixed at the particular position, and then it's separated in the form of bands. Then the tube is poured at the tip, and all fractionation were collected in the different tube. There is a detection system, so you can see as the molecules of the different types appears, this clearly indicates in the peak, and all three molecules are separated as per their different in their densities. To give you the idea about the types of density gradient centrifugation, it is are of two types. One is the continuous gradient centrifugation. For making the continuation gradient centrifugation, a gradient maker used to mix the liquid of the two densities. Lower density solution was added to outer side and higher density to the other side. It needs a rapid mixing in the chamber, and centrifuge tubes are filled from the bottom with a liquid of increasing higher density is placing the lower density liquid until the tube is full. So there is a gradient from the top to bottom with the increasing density of the molecules. You can see here the example of the continuous density gradient medium, the high density at the bottom and the low density at the top. If you put the blood sample here and then a spin, you can see all the blood component like the PMN, lymphocytes, monocytes, all are getting separated in the form of band at the different position as they achieve their density similar to the density of the medium. The separation of it is an example of the step gradient discontinuation gradient centrifugation, in which the gradient is the discontinuation, earlier was the continuous gradient. So here you can see here the blood component are separated on the basis of their difference in the density in the form of plaque. So describing an example of the histoplaque of 1077, you can see the lymphocytes and the other blood components are separated according to their size in the different density medium. So to run the density gradient centrifugation, the media selection is a very important factor. So in the media there are different kind of things. First is the aqueous buffer, that is the water based buffer that is used to separate the molecules with widely different S value. S is the Swedberg unit, for example nucleus from the ribosome. Sucrose or glycerol gradient used as a cushion for the isokinetic or the rate zonal centrifugation. Fixed concentration or the linear gradients increase the density and the viscosity and decreasing the sedimentation rates. That's why the sucrose is used. It preventing the sedimentation of molecules with the densities less than the medium. Controlling the time and speed of the centrifugation at a significant purification can be obtained. Since the most micromolecules have greater densities than these medium separation that is based on the S value, so it can be used to separate molecules with relatively close S value in the sucrose density gradient. The another gradient medium is the cesium chloride density gradient medium that is used for the isopycnic or buoyant density centrifugation. The linear gradient of these compounds in a buffer is prepared in the centrifuge tube. As the concentration of compound is increased, the density of the medium increases in the tube. Density is low at the top and high at the bottom, and macromolecule centrifuge through will form a band in a position equal to the once it reaches the buoyant density corresponding to their density, it will stop at a particular position, and useful for the separating molecules of the different densities even when the densities are very close. Although it's widely used but have some drawback that the cesium chloride can permanently inactivate some viruses. In other case, it is very useful medium and most widely used medium for the separation of biological molecules. We will discuss about the different types of gradient medium used for the separation of molecule in the gradient centrifugation. So before we are going to tell you about the properties of the different types of medium used for the differential centrifugation, you must know the criteria for the selection of the medium. So there are a very well defined criteria to select the medium. First, it is soluble enough to produce a series of required density. So usually insoluble molecules are not used, though all the molecules which are used for the gradient preparation must be soluble in the water. It does not form solution of the high viscosity in a desired density range. It should be either hyperosmotic or hypoosmotic when used for separating the osmotically sensitive particle. It should have adjustable to the gradient of pH and ionic strength at which particles are separated. So it doesn't have very sensitive to the different change in the pH or change in the ionic strength of the medium. It should not alter the biological properties of sample. It is a very essential parameter, because if it alters the biological property of sample, then it is the useless. Then it must be non-hazardous and non-metabolized by the cell. It should not be interfering with the assay procedure or not reactive with the centrifuge tube as well. It exhibits a property that can be used as a measure of concentration, like it has to be used as a probe. Then it is easily separatable from the purified product, and last, it is the autoclavable and cheap. So these are the certain criteria for the selection of the different gradient medium. Now we come about the different types of gradient medium are used, like the polyhydric alcohol. There are sucrose, which is it's used to separate the organelle, membrane vesicle, virus, protein, ribosome, polysome, etc. The glycerol is again a polyhydric alcohol. It is used for the separation of mammalian cells and proteins. Sorbitol is for the non-mammalian subcellular particles. Other components are the polysaccharide like the ficol, polysucrose, and dextran. These are used for the separation of mammalian cells, sometimes combination with the iodinated density gradient media. Mammalian subcellular particles are used, but this is the infrequent medium. The inorganic salts are also widely used for the preparation of the density gradient medium, like the cesium chloride, used for the separation of DNA, viruses, proteins. Cesium sulfate, used for the separation of DNA, RNA. Potassium bromide, used for the separation of plasma lipoproteins. Then the iodinated gradient media are also used, like the ditriozoate, mainly component for the commercial lymphocyte isolation media. Nicodens, it is for the mammalian cell organelle, membrane vesicle, and virus. Iodixanol, used for the separation of mammalian cell organelle, membrane vesicle, viruses, plasma lipoprotein, DNA. And the colloidal silica media are also used for the gradient preparation, like the percol, used for the separation of the mammalian cell organelle, membrane vesicle, and these are the used media for the preparation of the density gradient for the separation of biological molecules. Just we are further emphasizing that what are the criteria for the ideal density gradient medium and these are the criteria. The additive must be form a solution with the required density range. Addition must not interfere with or damage the sample. The solvent must be compatible with the sample. Solution must have refractive index within the particular range, so the parameters should be measured, and the additive must easily be removable from the sample. These are the ideal conditions. So any gradient medium should fulfill all these criteria before the selection. We will discuss about some additives used for the density gradient centrifugation. There are four main categories in which the additives for density gradient centrifugation can be categorized. One is the salts or alkali metals, second is the neutral water soluble molecules, third is the hydrophilic macromolecules, fourth is the synthetic macromolecules. So let's discuss first, that is the salts or alkali metals. These solutions fulfill almost every requirement for being a good medium. The high ionic strength, intramolecular hydrogen bonding in protein and nucleic acid protein complexes can be impaired by the chaotropic effect. Hence, such salts are mainly used during the separation of DNA and RNA. The most frequently used salt is cesium chloride. However, the other salts such as sodium bromide, sodium iodide, cesium sulfate, cesium acetate are also equally good. It is interesting to note that the hydration of the molecule is directly affects the density of the sample. The second category is the neutral or water soluble molecules. In this class of compounds, sucrose is most widely used because it is a neutral molecule. It has useful density range up to 1.29. Its range can be increased to 1.37 by addition of glucose or dissolving sucrose in D2O. Sucrose has very little effect on the macromolecules but affects enzyme activity because for an enzyme it acts as a substrate. Due to its high osmotic pressure, sucrose solution dehydrates cells and their organelles very efficiently. Glycerol solutions are the preferred media for the separation of enzyme because they do not affect the enzyme activity. They exhibit high viscosity, required prolonged centrifugation time. More importantly, however, glycerol penetrates the biological membrane. The third is the hydrophilic molecules such as dextran gradient has been used for the separation of microsomes. Separation achieved through dextran shows similar results to those obtained using the synthetic sucrose epicohydrin copolymer. In some cases, bovine serum albumin has been also applied, but the separation is an appropriate solution is very difficult. The fourth is the synthetic molecule. These molecules are the medium or the methyl glucamine salt of triiodobenzoic acid and metrozoic acid. It should be kept in mind that the parent acid of this salt may precipitate on adjusting the pH to the acidic values. We'll discuss about few examples. You can see a cell is infected with the virus and it can be taken and to analyze that what are the viral particles and what are the cellular particles. So it is simply centrifuged through the sucrose density gradient medium, and you can see here if you plot a graph, the cells infected cell and uninfected cells having the different graph, indicating that the infected cells can easily identified through the density gradient centrifugation. To give you another example that how the circulating tumor cells can be identified, you can see here the blood sample and it is in the medium, and then you can see the ficol was used as a medium and the leukocyte, erythrocytes and the tumor cells all are separated, so the tumor cells can be identified in a mixture of the cell using the centrifugation technology. We discuss about the equilibrium centrifugation. A macromolecular solution subjected to a centrifugal field will quickly attain a steady state condition in which the transport of solute mass occurs at a constant velocity and a concentration of gradient will be generated. If you spin very fast, eventually the entire macromolecule population will deposit at the bottom of the tube at a rate that depends on the centrifugal speed and the density and the viscosity of the solvent. But if we do not speed too fast, centrifugation and diffusion will balance each other so that the system will attain an equilibrium, which point net transport will cease and the transport velocity will be zero. This is because the transport of centrifugation by diffusion will oppose the balancing each other. Centrifugation will generate a density gradient and diffusion will try to eliminate such gradient. The rate at which the equilibrium is reached depends on the kinetic properties such as diffusion coefficient and angular velocity. The concentration of equilibrium is only determined by thermodynamic properties of the system and not by sedimentation coefficient or diffusion, etc. So we are giving you the mathematical expression of the equilibrium centrifugation. You can see here the mu total is equals to the mu chemical plus mu centrifugal, and it is used for the calculation of the delta G value, or you can see the expression that if you take the final equation, that ln C by C naught equals to omega square m2 and 1 minus v2 by rho divided by 2 RT into r square minus r naught square. That if you fitted this equation further, you can easily calculate mass of the molecule like the given by the equation, where the r value is gives the basic idea that what will be the molecular mass. For example, to calculate the molecular weight of the carboxyhemoglobin using the following data obtained from the equilibrium centrifugation experiment at r equals to 4.61 centimeter and at it is 1.22, and r equals to 4.5 centimeter, it is 1.061. Temperature is 293 K and spinning at the speed of 8703 rpm, and the specific volume of hemoglobin is 0.749, and the density of water is 1 gram per centimeter. So if you have the value of all these things, the molecular mass can easily be calculated using this equation for the equilibrium centrifugation. Another example of the calculation of the molecular mass of the hemoglobin and the different condition, and the all value are given here for the mathematical expression. So in summary, we have used the term density, that is actually the mass of the substance at particular volume, or you can say the gram per ml. That is the very important factor for the separation of the molecule, because it separates biological molecules based on their density. We discussed the differential centrifugation. This differential centrifugation separate the particle on the basis of the size by a series of centrifugation speed and the times. The other is the density gradient centrifugation, that the density gradient centrifugation is separation performed by supporting the column of solution which density of solution with increasing concentration are filled, and once the particle achieve their own density, it stops there. We also discuss about the discontinuous or step gradient. In the continuous or step gradient, it is simply non-continuous, and they have the gradient with the sharp change in their gradient from layer by layer. Then we also discussed about the isopycnic and rate or zonal centrifugation, that these two methods are used for the separation of the different molecules. So I hope that now you are well aware with the differential centrifugation, density gradient centrifugation, its application, its advantage, disadvantage, what are the different types of medium, what are the choice of the medium, what are the criteria for the selection of medium. These things you should be, it is very clear to all of you. Thank you very much.